And everyone, let's kindly get someone to raise up their hand so they can lead us in a word of prayer. Please raise your hand if you would want to lead us in a word of prayer. Yes, Zalma.
Good afternoon, everyone.
Good afternoon.
Let's humble ourselves for a word of prayer. Dear God, I thank you for bringing us to yet another day where we'll be able to study. I pray that you send your Holy Spirit to guide us, give us wisdom, knowledge, and understanding to understand everything that is going to be taught to us. Amen.
Thank you, Zalma, for that prayer. So before we begin, I just want to share with us a devotion for just 1 minute. It says, Power of your mind, Matthew 12:35. A good man out of a good treasure of his heart brings forth good things. God has given you the ability to imagine things with your mind. That's why your imaginative power is your creative ability. In other words, whatever you can imagine, you can create. You see, your mind is a powerful and important tool in deciding the direction you want to go in life. Therefore, it's important you don't allow junk into your mind because what you allow into your mind will eventually control your life. That's how powerful your mind is. So keep up the habit of studying the right materials, it, like the Bible. As you do, the word will guide your mind and produce the right thoughts always. You can say this prayer, this confession after me. I have the right mindset and I think only the right thoughts. I use my mind to create what I want or desire. In Jesus' name, amen. Thank you for listening. So, I am Teacher Martha, and I'm going to take us through chemistry today. And like I said, I requested for people to share the topics they studied, but I don't seem to see any. Okay, I'm seeing here chemistry and society, experimental chemistry, states of matter. Okay, that is good. Um, so we are going to look at the very first topic you're supposed to cover for term 2. But I am noticing for the people that have posted, I don't seem to see using materials yet. It's a topic you're also supposed to cover. So I'm not sure how many of us had covered it before we broke off for holidays. But either way, today we'll be looking at temporary changes. And if time allows and the holiday is not yet done, we'll look at using materials because I think most of us didn't cover it since we reported later to school. So I'm going to share my screen and I need to hear from Sonia. Sonia, are you online? Because I need some assistance when I start sharing. It may become a bit hard. If you're not available, I could make someone else a co-host such that they can assist me.
I'm available.
Okay, and you were silent, so I didn't know. So you're going to help me with those people who raise their hands. You will help me unmute them and also to read for me some of the responses in the chat in case some people post in the chat. So feel free to use the chat for the responses and please avoid crowding the chat with hello, hi, see you, all those things until the lesson is done. So let's restrict it to posting responses such that we are able to move together so that even the answers don't get lost in the so like I said, we're going to be looking at topic 1 of term 2, which is temporary and permanent changes. And I know these terms may not be so new to us, And I know that most of us may be able to relate with what temporary and permanent changes are. And as we navigate in the lesson, I would love to hear from you. So I'm going to request someone to raise up their hand so that they can read for us the competence and the learning outcomes. Because as we all know, every time we are covering a new topic, we need to know what do we expect to learn in that topic and what is expected of you to know at the end of that topic. Tanya, if we have some hands, you could request them to unmute such that we can read for us.
Yes,
Good
teacher.
Good afternoon, everybody. My name is Myra Luboa. Temporary and permanent changes. Competency. The learner and recognizes occurrence of temporary and permanent changes and their importance in everyday life. Learning outcomes. A. Understand that many substances undergo permanent changes when they are heated or burnt, forming new materials with substances change temporarily. US. B. Recognize temporary, reversible, and permanent in brackets irreversible changes to matter under different conditions.
Thank you so much, Rivoa. So, when you're looking at temporary changes, you're going to be expected to recognize the occurrence. Of course, we know that around us, there are changes that are already taking place, but are these changes temporary or permanent? That is one thing you need to know. And then also in the learning outcomes, because when you're given the activities of integration, these are the things they'll be testing for. Did you understand that some of these changes undergo permanent changes when they are heated or burnt, forming new substances, while others will change temporarily? And then, of course, you'll have to recognize the temporary changes and the permanent changes under different conditions. So basically, that is what our lesson is going to be about. Okay. So, we are going to look at the effect of heat on the different substances. And I'll request us to have our responses in the chat, or you raise your hand and then Sonia will pick you. When they request you to unmute, please unmute so that you respond. So of course we have different changes occurring around us. And what are some of the changes that happen around us? What are some of the things you've seen around you that we could classify as changes?
Sorry, teacher, for disturbing, but Jude raised his hand. Jude Thaddeus.
I'm here to give some of the changes that occurred due to the presence of heat. Some are expansion, evaporation, transpiration, and so on. Thank you.
Thank you, Jude.
And Jeremiah as well raised his hand. Oh.
Okay, there are no more hands or answers in the chat.
Physical change, chemical change, and
okay, thank you, Jeremiah.
biological change, teacher.
That's good, thank you.
And senior 2 ultra.
Well, I see chemical changes like metals rusting.
Okay, that is good, thank you.
And Marvel in the chat said change of weather.
Okay, that is good.
That's all.
Okay, thank you, Sonia. So those are some of the examples. Of course, in your book, you could write down some of the examples that take place around you every day. So all the changes you mentioned are actually correct. because they are things that happen every day and they describe what changes are really. So I have a few here, but of course the list is endless. Growth. For example, once you were crawling, once you were breastfeeding, but now you can walk on your own, you can think, you can reason things out for yourself. So that is all part of growth from childhood to adulthood. That is a change. And then of course we have boiling an egg. Before you boil an egg, it has a different kind of way it is, and after boiling it, there is a way it is. So that is also a change. Then freezing of water. Before you put water in a freezer, it is in liquid state. But after freezing, it is in solid state. And then, of course, digestion of food. S24 Ultra, can you please mute your mic? Because it's causing a lot of feedback. Thank you. So digestion of food, the food you put in the mouth is not what is actually going in the stomach. There is that process that is taking place to ensure that the food is broken down into smaller particles that can easily be absorbed in the body. Yeah, so we have some changes that are reversible while others are irreversible. So there are different substances I have here. So you're going to help me identify, are those substances reversible or irreversible? So we have the first substance as candle wax. Which category do you think it falls in?
It is irreversible.
Okay, candle wax is irreversible when we heat it. Anyone else? Thank you, Jeremiah. Though we may need to correct that projection. Yes, please. I'm okay. I'm in a lesson. Sonia, are there any other hands?
I'm requesting Patricia to please unmute.
Candle wax is reversible.
Candle wax is reversible. Okay, that is good. So we know that when we heat a candle, of course it melts, but you realize that after it melts, that candle wax on cooling remains as candle wax. So when we are looking at the reversible changes, we look at candle wax, heating of candle wax as a reversible change. The irreversible part of that candle is where you're heating or burning the candle wick. I hope all of us know what wick means, that car lead that you light. Because for it, once it's burnt, you can't recover it. So that one is the irreversible bit of burning a candle. So that one we say burning of a candle wick. So therefore it is irreversible. Wick is W-I-C-K. Then when we talk about candle wax, because it melts and eventually solidifies back to how it was, we call that a reversible change because no new substance was actually formed. And then heating salt, is it reversible or irreversible?
Jeremiah, please unmute.
It's reversible.
Come again?
It's reversible.
Okay, that is good. So because we are heating salt, no new substance is formed. That means it is reversible. Okay, thank you all for your responses in the chat. Then we have water. Is heating of water a reversible change or an irreversible change?
Teacher, it's a reversible change.
Very good. It's a reversible change because remember, when water evaporates, once it cools, it still forms water. So no new substance is formed. So as we take down those notes, we should remember we are going to draw some conclusions on what is happening to those substances. Then another substance is plastic bottle. Is heating of a plastic bottle reversible or irreversible?
Irreversible.
Okay, that is good. Thank you. So heating of a plastic bottle is an irreversible change. Okay, the last one is paper. Thank
It's
you for your response.
irreversible.
It's irreversible, very good. What happens when we burn a paper? What substance do we form that makes it irreversible?
Ash.
Ash, thank you, Jude. That is very good. So when we burn paper, we get ash, and therefore it is an irreversible change because we can't turn back ash into paper. Okay, so what conclusions do you draw from that assignment that we've just done? What could be your conclusion? What conclusion do you draw from the assignment we've just done above? Any hands or responses in the chat? We've been saying reversible, irreversible. So which conclusion do you draw from those suggestions? Is Fanya still there?
Treasure and Jeremiah, please, oh, Jeremiah, please unmute.
According to me, they are different type. I would conclude by saying there are different types of changes.
Yeah, thank you, Treasure. That is good.
Someone in the chat says some changes are reversible and others are not.
Okay, that is good. Thank you. So of
I
course,
Yeah,
sorry.
reversible changes are changes that can be taken back to their normal form, while irreversible changes are changes that can't be taken back to their normal form.
Okay, thank you. That is also a good conclusion. So of course, you're going to notice that we have changes that are reversible. That means we can get back the original substance. And then we have those changes that are irreversible. That means once the change has taken place, we can't have what we had initially. For example, for the paper, when we burn it, we can't get that ash and turn it back into the what? Into the paper. So that is something we needed to discover, that some changes are reversible while others cannot be reversed. Okay, and then of course, you may say chemical changes or physical changes. I've seen in the chat someone talking about biological changes. Of course, biological changes in this topic kind of embed themselves in the permanent changes because we don't look at it as a separate change. Because here we strictly look at permanent and temporary changes. So the biological change is sort of hidden within the permanent changes. Treasure, your hand is up. Is it a question?
I was saying that I was still saying that they can also be physical and chemical changes.
Okay, that's very good. Thank you. So here you may need to have your book and pen such that before you give me the answer, you first think about it. So we have think and share what happens in the assignment below and state the type of change. So Sonia, in case people post their answers in the chat, after we've heard from those who have raised their hands, you could read some of the answers that are different from what they have given. Because I also want to know what is happening in the chat.
Okay.
Thank you.
Zuraiz Ahmed said that for question A, he said that it turns into ice.
Okay, is it a physical change or a permanent change?
Yes. Say physical, man. Just say physical. I've told you. Physical.
Rose, are you giving us an answer?
Marvel, please unmute.
I think it's a physical change.
Okay, very good. So first of all, we are going to see that water turns into ice, and that is a physical change because no new substance is formed. It's just water, but in solid state. So no new substance has basically been formed. Okay, that is good. Then part B. Please, before you give us the answer, read for us the question such that we know what we are answering.
Someone in the chat said it dissolves.
Okay. We hear from those putting up their hands.
Patricia, please
I can
unmute.
speak.
Salt crystals are formed.
Okay, that is very good. Any
I
other?
can speak.
M and A, please speak.
Okay, so here I'm seeing in the chart, many people are saying it dissolved in the water and when heated, it forms the crystals of salt again. That is very true. So when we dissolve salt in water and then heat it, it evaporates to dryness, forming the salt crystals. So that is very good. What type of change is it? Is it a temporary change or a permanent change?
Sanchia said it's a temporary change,
Okay.
and many other people in the chat as well.
Yes.
Okay, thank you, Sonia. Thank you, everyone. So it is a temporary change. That is very good. You guys are very sharp. Okay, the next one. What effect does heat have on zinc oxide?
I don't know what zinc oxide is. First do, then I ask her to please explain what zinc oxide is.
What effect? Anyone who can try, who can crack their head and try. Remember, we are all learning, so don't be afraid to say something.
Please unmute.
I think it's sublimes.
I think it's sublime. Thank you, Margot. That's a good trial. Let's wait and see and confirm your answer.
Patricia in the chat said expansion.
Expansion, okay. Let's wait and see. We'll all confirm our answers at once.
It reflects and absorbs heat.
It? Okay, Aiden has a very good clue on what happens. So those following the chat, I think you can read her answer.
Techno KL5 said color change.
Okay, thank you, Techno. But remember in chemistry, when you talk about color change, you must say from what color to what color. You must mention those colors that are changing.
Its volume increases, mass remains constant, and expansion takes place.
Yeah, thank you. Okay, so I want us to watch this video, and after watching it, you tell me what happened to the zinc oxide. So please ensure that your eyes are on the screen to see what happens. So this is zinc oxide. Which color is it to those that are able to see? Before heating, I want you to take note of the color. What color is that?
White.
White, very good. So we are going to heat and see what color it changes to. So just keep your eyes here and you let me know what color it changed to and what type of change it is. So as we watch, have that at the back of your mind. What color is it changing to and what type of change it is? Okay, so what happened and what kind of change is that?
Patricia, please unmute.
Change of color from white to yellow, and I think it's a physical change.
Okay, thank you, Patricia. Okay, so we all watched the video and you notice that when it was exposed to heat, it turned from white to yellow. But immediately the heat was removed, the UV light was removed, you realize that it turned back to white. So in that case, we describe and say that the white zinc oxide turned yellow on heating and back to white on cooling. And because no new substance was formed, because there was no permanent color change, that means that substance, that change is a temporary change.
Teacher.
Yes, please.
Teacher.
Jeremiah, please speak. I'm hearing you.
There is a lot getting the teacher.
Well, thank you all for the beautiful responses in the chat. We go to part D. What effect does heat have on hydrated copper 2 sulfate crystals? Anyone that can try that?
Samsung, please unmute. Treasure, please unmute.
I think heat melts the hydrated copper sulfate crystals.
Okay, thank you. Though that word
Hello?
is sulfate. Are you able to hear me?
Yes, teacher, I can.
Okay. So we are going to watch a video still on this, and then you're going to tell me your conclusions. You're going to tell me if there are any color changes, and if they are there, which ones are they? And is it a physical or temporary change?
Hello everyone. I welcome you all for educational science experiments. In this experiment, we will demonstrate the action of heat on hydrated copper sulfate. When salts are heated strongly, they undergo chemical change. If we heat hydrated salts, they lose their water of crystallization. In this example, spirit lamp, hydrated copper sulfate, which is...
What is the color of those crystals? Who has seen them? What color are they?
Samsung, please unmute.
Yeah, they are blue.
Okay, that is good. So let's watch and see what happens when they are heated.
Hydrated copper sulfate, which is a blue crystalline salt. Blue and red litmus papers, lighter, water. Make the litmus papers moist. Add copper sulfate salt into the test tube.
Excuse me, teacher. Someone in the chat said that they're not getting the sound.
But are you getting it?
Now the
Yes,
salt
teacher,
is
I can get
ready.
it.
Okay, let them just keep following, or
Fix the test
alternatively
tube
come back
in the stand carefully. Now light the spirit lamp and place it under the test tube to heat the salt. Adjust the height of the test tube. Change the position of spirit lamp to heat the salt properly. Make sure the salt is heated properly. Observe the change in the color of the salt. See, the blue crystalline salt changed to white amorphous salt. Test the nature of the water vapor formed using litmus papers. Observe the formation of water vapor on the sides of test tube. Both the litmus paper do not show any color change, indicating that water vapor is neutral. Hydrated copper sulfate loses its water of crystallization and changes to anhydrous copper sulfate. Now keep it aside for a while to cool. Observe the colors change. Let us see what happens if we add water. Again it changes to blue. That is, it becomes hydrated copper sulfate.
Okay, so here, of course, the video has gone past ahead a little. But when you look at this experiment, I'm going to replay it, but I'm going to remove the sound of the lady. Then I'll be explaining what she's doing. So just pay attention as I replay the video again. So, of course, this is important information because every time you're carrying out an experiment, you're expected to have the materials that you're going to use. So instead of the spirit lamp in our laboratories, we use the Bunsen burner. But of course, whatever is available to produce the heat source is what you will use. So of course, you see she has a test tube rack, and inside it there is a test tube. And then we have the spirit lamp, which is going to use, and then of course the copper 2 sulfate crystals, which are blue. And then she has water, which is going to use to find out the taste of the water once we start heating the copper 2 sulfate. Because remember, it's saying hydrated, that means it has water in it. When something is hydrated, that means it has water. So she has a lighter, which is going to use to light the spirit lamp. Of course, those are the litmus papers, the blue litmus paper and the red litmus paper. But of course, that information for now may not really be necessary. But when you get into senior 2, you may need to know those. But for now, it may not be that necessary. But there is no harm in knowing. So that bottle that she's holding is the one containing the copper 2 sulfate. So she's going to transfer some copper 2 sulfate into the test tube. And of course, you're going to see some blue solids in the test tube. So she's going to light and heat the copper 2 sulfate. So as she heats it, you're going to notice that there is a color change that takes place. So that white substance formed is called anhydrous copper 2 sulfate because now all the water has been lost, and you can notice that the test tube has some moisture on it. So that means as she heats it, that water moves out of the crystals and is on the test tube walls. So even when she tests with the litmus paper, because there is no change on the litmus paper color, that shows that it's water. That liquid on the test tube is water. So you notice that after heating completely, the substance turns to white. So in that case, you're going to notice that once she adds some drops of water, when the test tube has cooled, because of course, when you add water and the test tube is still hot, we expect something to happen, it will crack. So that means she needs to cool it a little, and eventually we'll add some drops of water. And when she adds some drops of water, definitely it turns back to hydrated copper 2 sulfate, which is blue. And that is what we are going to see. So once exposed to water, it turns back to hydrated copper 2 sulfate. So what type of change is that?
Aiden said that it's a temporary change.
I think it's a chemical change.
Why?
Because it's a chemical. It's like because there are two chemicals, and yeah, I think it's because there are two chemicals.
Okay, thank you. Anyone else?
Many people in the chat are saying temporary change as well.
Okay. So, something we are going to notice is if we are talking about temporary change, it comes in the fact that it is reversible because we can get that substance back. But then in the context, we look at it as a reversible chemical change. But in real context, we would notice that it is a what? It is a temporary change because it changes temporarily, but then we are able to obtain back the original substance. Okay, you people are very brilliant. I like this class. So let's continue. Temporary changes. So we've been talking temporary changes, temporary changes. So what are temporary changes?
I think temporary changes are changes that can be undone. Like you can change them back to their original state.
Okay, that sounds better than undone. Thank you. Anyone else?
Temporary changes are changes which do not last for long.
Okay, thank you.
Temporary changes are changes which are reversible. These are changes where the change is reversible.
Okay, thank you.
Temporary changes are changes whose substances can be regained back, whose original substances can be regained.
Okay, that is good, thank you.
Sanchia in the chat said these are changes that are reversible.
Okay, thank you. So I think all of us literally have the same answers, though in different versions. So allow me wrap up at that. So when we are looking at temporary changes, of course, we've been looking at the reversible changes as temporary changes. And I know the word temporary comes with that context that something is not there to stay. It can eventually change because it's a temporary thing. So temporary changes are those changes that are reversible, or the original substance can be obtained back. Then temporary changes can also be called physical changes, because I kept saying some of you mentioned physical changes. So basically, physical changes are those temporary changes. Then can we give some examples of temporary changes? And as you give the examples, please ensure to, how do they say? To give us what substance it is, what it turned to, and what it turns back to. I don't know if that...
I think freezing is a temporary change because, like, if you have ordinary water and then you freeze it, it becomes ice. And then when you heat it again, it turns back to water.
Okay, very good. That is one good example. Anyone else?
Someone in the chat said condensation.
Condensation of what over? Please, students, learn to give your answers in a complete format. Don't just say condensation. Now I'm wondering, condensation of? Okay, we're being good by using the chat for only responses. Can we get back to that goodness of using the chat for responses? Because we have questions here and we can't check the chat and there are people insulting others. So can we please maintain the discipline that we started with? Sonia, any responses or hands?
Sanchia said evaporation of salts. Patricia said evaporation of water to water vapor. And Kat said sublimation of mothballs.
Okay, that is very good. So all those responses are good. Sonia, looking at temporary changes, most of them are actually changes of states of matter. And I know you've all looked at that topic. So the changes of states of matter mostly fall under temporary changes because you can eventually get back what you had at first. So anything that involves freezing, though you don't have to just say freezing, freezing of water to ice, and then evaporating that ice back to water. And then, of course, you look at condensation of water, vapor, evaporation. So you look at all those sublimation. For example, heating iodine, sublimation of mothballs, sublimation of naphthalene balls. So you look at all those and put them under temporary changes because no new substance is formed. And of course, even when there is a color change, we realize that that color change comes back. For example, when we looked at the heating of zinc oxide, it turned yellow, then back to white. So remember, we are working with chemistry and you should learn to relate with those chemical terms. So when you talk about heating zinc oxide, which turns from white to yellow and then back to white, that is also a temporary change. And then, of course, we also look at the heating of candle wax, melting of candle wax, because eventually, once it cools, it's going to still form the wax that we had. So those are some of the examples that I think we really need to take notice of. And then also, I hope you're noting down, because it's very important that every time you come in for a lesson, you're able to note down. So this occurs when there is only a change of state and the shape of the substance. Okay, so we go to permanent changes. What are permanent changes?
So these are changes that cannot be taken back to their original form.
Okay, that is good. Any other?
Now, these are changes that are irreversible.
Okay, that's good. Any other?
Permanent changes are changes that are irreversible.
Okay, good.
Permanent changes are changes that are irreversible.
Okay, that is good.
Joshua in
So,
the chat said permanent changes are changes that cannot be reversed.
okay. So basically, when we are looking at permanent changes, when something is permanent, it's there to stay. It's going nowhere. So that's the same thing with these permanent changes. Permanent changes have come to stay. So that means they are irreversible. Once that change happens, it has happened. Okay, so it is also called a chemical change. So sometimes so the other name for permanent changes is chemical changes. And of course, here you're going to see that in these chemical changes, chemical reactions are taking place. For example, when you heat something, it is able to react and then give you another substance. That is why we basically call them chemical changes. Any examples of permanent changes?
My examples
Yeah,
are burning, rusting, and burning and rusting. There are many more, but let me leave them to the others.
Thank you. That's good.
Yeah, cooking and cutting down a tree.
Okay, that is good.
Many people in the chat are saying burning, rotting, decomposition, digestion, and germination. Oh, and also growth.
Okay, those are very beautiful answers. Thank you, Sonia. Thank you to those that have contributed. But like I said, when you're talking about burning, burning of what? So please be specific. So when you talk about burning, talk about what burning you are referring to. So those examples of permanent changes, we have burning of pepper to ash, burning of a tree to charcoal, cutting down a tree, growth, like all the rest that you have suggested in the chat. So we have some more investigations on changes. What happens when an egg is boiled?
Oppo, please unmute. Oppo, we can't hear you. So Jeremiah, please unmute.
Changes from liquid form to solid form. The insect.
Letter, please unmute.
The egg white and the yolk hardened from the inside.
Someone in the chat said its inner components permanently change or transform or form liquid to solid.
Okay.
Excuse me, teacher. Excuse me, teacher. Why does the inside part of the egg turn solid, yet when other liquids are heated, they evaporate?
What happens when an egg is boiled? When the egg is boiled, the heat causes the proteins in the egg white and yolk to denaturally and solidify, transferring them from liquid to solid. Thank you.
Galaxy, please unmute.
It becomes solid. Thank you.
Thank you for all those responses. There is a question I had of most liquids when heated, they evaporate. And why doesn't an egg evaporate? Who asked that question? I want to respond while asking you a few questions. So if you don't mind, please raise your hand again, such that I had someone give you a response, which was very good, but there is something I need to clarify.
Teacher, it was me.
Okay, so why do you think that egg solidifies instead of evaporating?
I'm not sure.
Could you try to think? Because, for example, if I put water in a kettle, that water is not going to solidify. But when I get an egg, it has a shell in it, and the egg is inside the shell. And obviously, someone I think is asking why they are different colors. But even when you beat that egg, if you're going to fry it, you notice that the yolk has a different color, and then the white part of that egg is also a different color. So when you look at the egg and the water, the egg is in an enclosed, how should I call it? In an enclosed kind of surface. So that means when you look at those eggshells, it's not going to be able to allow that liquid, because it's even a semi-liquid, because you realize that it's a bit slippery. It's not more like water. So that means that semi-liquid is enclosed and engulfed within the eggshell. That means it has no space to evaporate. Therefore, it is going to solidify. Have you gotten the point?
Yes, teacher, thank you.
You're welcome. So, I've seen a few comments and I kept hearing some answers. So, that egg, when the egg is boiled, first of all, that is a chemical change or a permanent change. And of course, it forms a boiled egg, if that even makes sense. Then the second investigation is what happens when a piece of paper is burnt.
It turns into ash.
It turns into ash. Very good. Is it a physical change or a permanent change?
It's a permanent change.
Very good. So because when we get the ash, we can't get back the paper. Okay, we have the next investigation. What effect do you think heat has on aluminum dichromate?
Letter, please unmute.
What effect do you think?
Teacher, I think it evaporates because it makes it decompose and then it produces nitrogen gas.
I think it until there is no further change.
What effect does it have on ammonium dichromate? What effect does it have on ammonium dichromate? Hello, can I be heard?
It seems that teacher isn't here in the meeting with us, so just in case you have any questions to ask, raise up your hand and you never know, we can help you with a question.
Okay, Sonia, please click on my name. I don't know if you're using a phone. Click on my name and make me a co-host.
Okay, teacher. Teacher, I've made you a co-host now.
Thank you. So, I don't know if you're able to hear me because there is some noise in my background. Are you still able to hear me?
Yes, teacher, I can hear you.
Thank you. Pardon the noise in the background. So I was still asking about the effect, and I went off really. So the effect of heat on ammonium dichromate.
Sasha, please unmute.
Okay. So heating ammonium dichromate causes it to decompose and produce nitrogen gas.
We are really interested in the color changes because remember, at this point, we need to know what color changes are taking place such that we are able to tell whether it's a chemical change or a permanent change. But thank you for that response.
Jude, please speak.
The ammonium dichromate will change from orange to green.
Orange to
green.
Okay, that's very good. So is it a permanent change or a temporary change?
It's a permanent change.
Okay, that's very good. So the orange substance turns to a green substance, and therefore that is a permanent change, which is also called a chemical change.
Because of these risks, I'm wearing closed-toed shoes, protective gloves, and safety goggles. This demonstration should only be done by a trained professional and should not be tried at home. Chromium salts are going to be used in this demonstration, and they will be properly disposed of after this demonstration because they are toxic to humans and the environment. Also, this demonstration should only be done in a fume hood. Hi, I'm Casey Rogers. I am an undergraduate chemistry major at James Madison University. The demonstration I'm going to show you today is called decomposition of ammonium dichromate. So I have some ammonium dichromate here in the hood. It's an orange solid, and I've piled it up to look somewhat like a volcano. So I'm going to add this piece of paper that's been soaking in ethanol. This is going to be our fuse. I'm going to add this to our mound. If I can get it to stand up, which doesn't look like it wants to work. And now I'm going to light our fuse. You can see this is a very exothermic reaction, and it's decomposing quite rapidly. Ammonium dichromate decomposes to chromium 3 oxide, which is the dark green solid that we can see. This has been Casey at James Madison University. Thank you for watching. To stand up. Wants to work. And now I'm going to light our fuse. As you can see, this is a very exothermic reaction, and it's decomposing quite rapidly. Ammonium dichromate decomposes to chromium 3 oxide, which is the dark green solid that we can see. This has been Casey at James Madison University. Thank you for watching.
Okay, so of course that is a chemical change of the orange aluminum dichromate turning to a green solid. So don't say dark green, but rather just leave it at green solid. That is also okay. So I want us to look at another one.
Excuse me, teacher. George,
Yes.
George seems to have a question. So, George, please unmute. It's okay, teacher. You can continue. Oh.
Such things are there.
We have another question here. What effect does heat have on copper 2 carbonate? What effect does heat have on copper?
Who's the what? When you're signing in again, when you're signing in again, it's George, I think. What was the question?
Any responses?
All depends to what. I want them to be.
Okay, so this is the last video you're going to be watching. King Von, you're saying you have a question. What's the question? You can raise your hand and then Sonia can ask it 1 minute.
Who is that? The sun?
I think so.
Yeah, we said it changes color. It changes from orange to green. And because that green does not turn back to orange, that means it's a chemical change, like we saw in the video.
Yeah, they'll just be there like this.
Asnat?
When copper carbonate is heated, it decomposes and breaks down into copper oxide and carbon dioxide gases. When it's heated, it's green, as the copper carbonate is green, and when it's decomposed through the heat process, it produces a black gas, which is copper oxide.
Okay, that is good, but we need to improve it a little, just slightly. It produces a black solid, not a black gas. But otherwise, thank you. That is very good. So let's watch a video on that as well.
Metal carbonate. The metal carbonate decomposes to give carbon dioxide and the metal oxide. We heat a sample of copper 2 carbonate. As we heat the copper carbonate decomposes to give a characteristic flat copper oxide. The carbon dioxide that is released is bubbled through lime water. The lime water is a solution of calcium hydroxide. The carbonic acid and the calcium hydroxide react to produce calcium carbonate, which is insoluble. The lime water turns cloudy because the carbon dioxide, as it bubbles through the water, produces carbonic acid. Copper carbonate decomposes.
Okay, so I want us to see this. Realize that originally the copper 2 carbonate is green, but when heated, it's turning to black, and that black solid is called copper 2 oxide. So of course we have copper 2 oxide being given off and then carbon dioxide. That's why you saw the other lime water turn white, because of the carbon dioxide gas that is being given off. But that is not our interest for today. So our interest is in seeing this part here where the green solid turns to a black solid. So once that happens, that means it is an irreversible change, and therefore we conclude that those are chemical changes. So I hope you were able to learn something today. I'm going to give us an assignment which we'll begin with next week. So you're going to find the differences between chemical changes and physical changes. That means you're going to find the differences between permanent and temporary changes. So if you get your solutions, you can post them in the group. I can mark them and revert. But otherwise, that's where we'll begin from our next lesson. But before we log off, I want to know from us how many of us studied using materials, because it may be something we may need to look at instead of going to another topic, because after looking at those differences, we'll close that topic from there. If you looked at using materials, can you please raise your hand so that I can know how many of us had covered it at school? Okay, since there are no hands, it seems all of us hadn't covered it. Okay, only Trisha. So I think that could be the next topic we could look at next week after looking at the differences between permanent and temporary changes. So thank you for being a good class, and ensure to do that assignment that I've asked us to do. And see you next week. Bye-bye. Enjoy your weekend. Sonia, before you close the meeting, I may need to stop the recording such that it's saved.